Hello, everyone. Welcome back. We've got another session here from Saúl from the Jitsi team. So he works for Jitsi /8x8 because 8x8 are the guardians of Jitsi. So he's going to talk to us about how they scaled up the number of people that you can have in a Jitsi room, which is really quite an interesting talk because the first time anyone said, "Oh yeah, can I have 100 people like all ready to talk in a room together?" and I tell you that was a ridiculous notion. But Saúl explains why it's a good idea. So I won't take anything away from his talk. So I do want to say thank you to all of our sponsors. Some of you might be getting a bit bored of me talking about sponsors, but ultimately, without sponsors, you would all have had to pay for ComCon, and you would have all had to pay for this content. And instead, you get it all for free. So our platinum sponsors, Subspace, Daily, Element, and Mux. Our gold sponsors, Taloo, 100 Milliseconds, and Dite. Silver sponsors, Lowway, Sangoma, Millicast, WebRTC Ventures. Community sponsors, Jambones, Telecurve, and Pion. And then our AV partners, PSP, Millicast, Broadcaster, Subspace, Element, Mux, and Meet Echo. So yes, without them, this conference wouldn't exist. Our platinum sponsors and our gold sponsors have matrix rooms. So please go talk to them during this live week, because if you don't, then they might not sponsor again. It's as simple as that. So let's get on with the talk, and we'll be back for some live Q&A with Saúl afterwards. So take it away, Saúl.
Hey Dan, of course, thanks for having me. I'm pumped to be here back at ComCom. And well, as you mentioned today, we're gonna talk about how we took Jitsi Meet to the next level when it comes to, scaling the number of participants. People know Jitsi by being another video conferencing solution. It's open source. You can self-host it. You can build applications with it, embed it in your own applications that do other things. And today we're going to talk about how we grew the amount of participants we support in a single room from not quite 100 to actually 500. When the pandemic hit and lots of people started using our software, this was probably at the top of our requests, right? People wanted larger meetings, and it took a while for us to actually, it sounds simple, like, yeah, I just want more people, but at the same time, it didn't quite make a lot of sense to me, for instance, personally. This is how it looks, pretty busy. And not everybody has video, and this is actually a test harness that we're going to talk about now. So what I'm saying, the reason why I'm saying it didn't make much sense to us is because, or to me rather, it's because I think a meeting with 500 people is like a hen house. That cannot possibly work, can it? So the answer used to be, well, why don't you go ahead and just have a small meeting with the people that actually need to do the talking, and then the rest will join via live stream. This works for most of the cases, but in practice, there are other cases when it doesn't. Imagine an investors kind of meeting where there might be hundreds of people, and there's someone presenting the numbers, and at the end there will be some questions. And switching from being on a live stream to being actually live participating, you would need to make that work. Or a company all hands. We have actually used this at ours. So those are the cases when this finally made sense. So we set out to build it. How did we build it? Well, step 0 is testing. How are we going to know if we reached that number? We need to be able to simulate 500 participants in a meeting. Otherwise, we're not going to be able to know if we have accomplished our goal. So we built a pretty large Selenium grid. We use Selenium to drive Chrome browsers in general, but we tested this with Chrome mostly. But we had to write our own thin client, which actually runs without any user interface. In the previous slide, you saw the Jitsi user interface with all the participants being rendered. lots of bells and whistles, VU meters for audio, mute indicators, lots of GUI elements. And all of that takes some processing amount. But without any user interface, we can actually keep our Selenium nodes smaller because they do have a cost. So running these tests are actually, it can actually cost you some money that is not negligible. These thin clients, we had to make them configurable to have a certain amount of senders and receivers. This is to simulate like a real kind of 500-person meeting, right? In general, we think of a 500-person meeting with few participants sending, but everybody is receiving. And we want to be able to tweak this and think, okay, how do things look if 4 people are sharing their video, if 20 people are sharing their video, things like that. So we built this tool to help us see where we were at and how were things going and measure along the way. So first test, how did it go? Terrible. The UI froze all the time. Many endpoints couldn't really join. They had like spinning wheel forever, and our servers were overloaded. So we had some work ahead of us. So let's start from the front end because it's sort of what's closest maybe to the client. We noticed that there were a lot of improvements we could make in rendering. There were a lot of things that didn't need to be re-rendered being rendered. In general, this was not a problem for us before, but if you multiply that by 500, well, it becomes a problem. We had, like, Jitsi Meet is actually a code base that has been along for a while. And this means that, we've been around since before React, then functional components, then hooks, you name it. So our code base has a little bit of everything. And some parts we're still using what we call the legacy code, which is code that was not using React. And we started by refactoring those parts into React because this way we can have tighter control over the rendering. We know what components are rendered and how we can have like everything in a single rendering tree instead of having a bit in React and like a bit in jQuery. And here we introduced the first key component of achieving these numbers, which is pagination. In general, in a 500 participant meeting, you not actually have 500 tiles in your viewport. You have maybe 25 or something like that. But before, what used to happen is we had like a scrollable area and there were 500 tiles, let's say. And even though they were outside of the viewport, they had video elements, they were attached to remote videos, if any, so on and so forth. So in this stage 1, we started by, well, we're going to only render video elements and indicators, everything basically. Don't do anything for tiles that are not in the visible area. We're going to lazy load all those participants and move forward. Let's see how that improved things. Well, the first achievement that we unlocked is that we could actually do 100 participants reliably, which before was really not the case. This unlocked that first milestone for us. Then we continued with further improvements, but let me take a second here and hammer on pagination and why is it one of the keys to success here. As I mentioned, you don't see all of the 500 thumbnails at once, and you don't only want to optimize for rendering what you see on the viewport, but also we want to tell our backend, hey, I don't have this participant visible on my viewport, so I don't care if they're sending video or not, just don't send it to me, because I don't need decoders in my system to be doing work that they don't need to be doing and higher CPU than I need to, because I'm not seeing it, so it doesn't matter. So step 2, we did this, but in the backend. So the clients can inform the server, the Jitsi Video Bridge, which participant we have in our viewing area, and thus we can avoid the server sending video data for participants that we're not looking at. And if you scroll, we can ramp up really quickly, and is in like you cannot really tell. And this way, we can actually, even if everybody was sending video, imagine 500 participants, you would only receive video for the ones that you're seeing. So let's say 25. And this really improves things to a point where at this stage, we accomplished 500 participants, sort of. So it kind of worked, but it took like over a minute to join and even longer to leave. Like you click the leave button and you would stare at the screen for minutes, and then like finally you would be gone. So there was still a long road ahead. So next up, we needed to dive deeper into React. Like our application is reasonably complex. There's many moving parts, and like the main thing for this, for what's the grid of participants is what we call the film strip. So the data model that we were using before to feed it wasn't really all that great because it was prone to re-rendering things that were not really needed. So we optimized it and changed the way we structured the data so that it was easy to avoid rendering things that we didn't want. For example, let's say the mute icon in a like the participant's mute state changes. You don't want to render the whole thing. All you want to render is that teeny tiny icon. So very deeply nested component structures. We want to make sure that we don't have like, a huge rendering kind of domino effect. That was really important to get more performance. We use Redux for state management, and we dispatch actions for almost everything that happens. But sometimes, we need to dispatch lots of actions when things happen, and by batching them together, we also improve the performance by not, having to do that effort more than once. We also change a lot of components to pure component. I know some people are going to think, but what about functional components? As I mentioned, our code base is pretty large. It's got class components, functional components, a little bit of everything. But the point here was we needed to optimize our components so that they wouldn't be re-rendered, for instance, when their parent is re-rendered. But if the props pass to a child component, we didn't want to re-render the whole of it. Because as I mentioned, and I'm going to say a couple more times, when you multiply it by 500, the tiniest bit that you gain, it will have a huge impact. And this actually, these four things helped us really get those join and leave operations on check. They were finally at a point where the experience was, what you really expected. So we accomplished that. Good join and leave times. Still, there's more work to do. I want to mention one interesting React gotcha that we found because of our large code base. Because we have class components that use map state to props, and we had some functional components that use selector to grab pieces of the state, it turns out that if you have like a parent component using being a class and using map state to props, and a child using use selector, the operations seem to run in like different execution queues or something. And then it wasn't very deterministic which one was going to be re-rendered. And we ran into a few snags because of it. And this actually caused us to rewrite a few functional components into class components, which sounds kind of backwards in 2021. But I think we're going to need to dive a little bit deeper in this one. But this was one of the things that bite us a little bit. So I thought I'd mention it for those who are, navigating a large React code base and wanting to accomplish something like this with like a million components being rendered at the same time on the screen. Next thing we tackled is signaling. In signaling, less signaling is more. I mean, I know it's cliche, but it is what it is. We use XMPP for signaling, and those of you who know XMPP may know that when you join a group chat or a mock, we use presence stanzas for participants, and we actually use attributes in the presence stanza to represent things like the muted state. We also change affiliations if you join and suddenly become a moderator, and so on and so forth. So it was like when you join, there's a little bit of a presence storm. And this was critical to keep join times in check, but also keep our server CPU load in check. Otherwise, poor prosody is going to spike to 100%, and then everything will become slow. So we reduced the amount of presence stances that we send. Again, just like with everything, when you don't have when we had less than 100, things were manageable, but then multiply and they're not. Also, in the beginning of the conference, we needed to do some discovery, and we used some caching strategies and coalescing of some signaling packets to reduce the number of messages that one needs to exchange before you actually join. I think this concept can apply to other signaling mechanisms as well, because the less round trips you need to make to negotiate everything and finally join, and less messages every time a participant joins, is like there will be less load on your signaling server and a lot less work that you as a client also need to do. Then we included, modified the prosody to queue and rate limit participant joins in case you have a storm of 100 participants joining at the same time. You want to allow them in batches, otherwise the whole thing would be overloaded, let's say. So we worked on that as well. And then maybe a slightly more controversial one, we changed some jingle messages for SRCs to be JSON encoded instead of XML, because this actually simplified the parsing in our own backend, but also prosody, because it's not jingle, it's not the stanza. It will not look inside of that part of the XML, so it will be cheaper to parse. And this also further improved the join times that we had. Moving forward to the WebRTC side of things, we were doing add track and remove track operations, for instance, for muting in certain browsers to make sure that the little camera LED is off. When we switch to replace track, SSRC changes are fewer, and this means that we need less signaling. A good one as well, exportable to pretty much anywhere, is we're using now get synchronization sources to gather audio levels instead of using get stats, because it's cheaper to parse. And also a further optimization we did is that we're not grabbing the audio levels for every participant in the conference as we were doing before. These APIs are expensive for the browser to run. And what we do instead is the backend can tell us what are the last, 5 speakers. So we gather audio levels for those last 5 speakers. And if a new speaker comes in and joins this list, we're going to start gathering audio levels for it as well. And it will show the nice VU meter on the interface. Well, there's mobile as well, which was part of the deal. Here, the idea was to build 500 participants for everybody, so for web and for mobile. So we needed to do some work there as well. I haven't mentioned this for web because it was already there. So on the web, we were using WebSocket as our signaling transport, but on mobile, we were still using BOSH. So BOSH is a way to do XMPP over HTTP, and it uses long polling. And this basically means that when you join a conference with so many participants, you're going to create so many HTTP connections to get your new messages. It's insane. So by switching to WebSocket, which we are now in testing phase in production, it's implemented, and we're going to flip the switch real soon. We dramatically reduce the join times on mobile. If it takes, if it took all this work for the web to actually have 500, imagine on a poor phone, right? Even though they're pretty powerful these days, but still. So now one thing to remember is that everything I said before applies to mobile as well, because the app is built with React Native, so it shares the entire code base with the web. So this is in addition to what we did for the web, we did just a few things for mobile. Also, for example, we had 2 verbose logging, and that can also be taxing, because in React Native, you're logging from the JavaScript thread, and then it ends up in a native logger. So, it's a death by 1,000 cats. So you keep chipping away, and eventually you arrive at the point where things start to work. Now, even when you get everything working, it turns out that performance, well, it's a lot, but it's not everything. You start suffering some user experience problems. We have these little notifications that show up when a participant joins. Imagine what happens when you join a meeting with 500 people, right? It becomes insane, even though they vanish after a little while. But imagine 500 buzzes, 500 things showing up. It just makes no sense. So we optimize some of those things, some notifications to like not show up. If you're in a 500 in a 500 person conference, what does it matter if somebody else joins? It's like, it's kind of irrelevant at this point. So we try to be a little bit smart about when we show you notifications, because if it's too crowded, it's going to be on your way rather than help you know something about the state of notifications, and also coalesce them, like tell you that 20 participants have joined, because that's what happened in the last 5 seconds, instead of telling you 20 times one participant joined. Little things like that. And a very, very important one was also related to improving the user experience in large meeting is introducing advanced moderation. So as I mentioned, like I imagine a 500 participant conference as the hen house, and it kind of is, unless you are allowed to actually, give voice to a participant, decide that everybody's muted, and only you can tell people, hey, you're free to unmute now. If you want to talk, raise your hand and I'll give you the ability to unmute yourself. So we implemented all of that, which we had always kind of shied away from because, well, it's complex. It's got interesting UI interactions, but at the same time, if you don't implement some kind of moderation controls for a large meeting, it becomes unusable. So that's what we had to do. Sorry about that. So with all of this, performance improvements, user experience improvements, with that, we unlocked our goal, which was to get 500 participants in a meeting from web, from mobile, with good performance. This is how it looks on the web. This is actually one of the tests we did with QE teams. So you see a lot of participants that are kind of fake. These are the Selenium Grid participants that inject a random video there, and then it's us doing some testing. So what did we learn implementing this or doing this effort? Well, when you start, it seems impossible. And when you're done, it's like, how the hell did we do it? I actually had to reach out to many colleagues because this was truly a team effort, so that everybody would chip in and remind me what everybody did, because there's so many people were involved. So I would say, if you're facing a similar problem, don't let it overwhelm you, because it's progress is made quickly. So you change this rendering thing, you get a little bit more, you get a little bit closer, a little bit closer, a little bit closer. Leave no stone unturned. So as I mentioned, we modified every single piece in the stack, needed some adjusting. So just make sure that you look at everything and say, well, is there anything I can do in this component to make it better? Because chances are there is something you can do. Then really, really critical is to make sure you have a way to track your progress. So you have this testing harness, you can measure how long it takes for things to happen, so you can see how close you are to your target. Otherwise, it's just guesstimations. If you need to do something this specific, you may need to make your own tools or kind of adapt. We didn't quite build, we had like an XMPP stress thingy that we used a little bit, but what was really important is this thin client that basically was another Jitsi Meet user, but without any UI. That really helped us save on cost and run our grid a lot faster than it would have otherwise run, to be able to ramp up all these 500 participants so you can test this stuff. And as I've mentioned a million times already in this presentation, even the tiniest stuff multiplied by a large amount ends up being, well, a large amount. So by all means, don't skimp. When you're chasing performance, you need to change that mindset to not kind of take the shortcut and involve the whole team. I think everybody in the Jitsi team has worked on something related to the project 500 participants in 2021. And I don't think we would have arrived at the result had this not happened. So you're going to need to reach out to everyone, because front end, back end, signaling, everything needs a double check to make sure you arrive at this. And with that, I will take some questions.
Thanks so much for that, Saul. Anyway, let's bring Saul back in now in real time and say hello. So thank you for that. So I think it's still staggering that you can have that many people all together in a state where they can do all of that voodoo.
Yeah, it was a big effort. Thanks, Dan.
I can't even imagine all of the front end, like having all those little things that you were talking about, like tracing all those like all the states and moving stuff from functional over to class, and which is like backwards to some people. I personally prefer React class components rather than functional components, but never mind. So my first question, my question to you will be, what's coming next? Like this has been quite a big thing, right? You said in your talk that like absolutely everyone within the Jitsi team had something to do with being able to enable this. So I guess, and it's a big thing, and it's a lot of work. So what's next within Jitsi world?
Right. Yeah. So first, let me give another shout out to everybody in the team because yeah. So the work started before I took some time off for paternity leave. Then I came back, and then work was underway. I took part of it, but it was very like when you looked at the whole problem, it was like impossible to solve until you start chipping away, and then you start seeing results, and it becomes super encouraging because you see progress, and then you want to like squeeze some more performance here and there. So improving performance on basically everything is on the table. I know we have places where we can push things, for instance, to web workers, all the video effects on browsers that support transferable streams. At the moment, I believe it's only Chromium browsers and surprisingly Safari. You can transfer a stream to a worker, and we can do the offsite canvas rendering there, for instance, to do the composition for things like virtual backgrounds. I hope we can do some work there. We, for example, late last week, we released the first version of breakout rooms, which is also something pretty big. This huge shout out to Werner and also the European Commission that sponsored a hackathon where this was born. So we got this actually in a contribution. It was a huge contribution, but a contribution no less. And this happens actually pretty rarely. Contributions tend to be smaller. This was huge. UI included and everything. Now, usually when the work is so large, at one point it becomes a target of ours to land that feature. So we kind of embraced it, gave it a design overview, both UI wise, but also implementation wise, and then kind of pushed it over the finish line, and it landed. We're going to have a new stable version real soon, fixing some more issues, and we're going to make some more progress there. And we have actually released a number of interesting things already that we have kind of failed to properly communicate, to be honest. For example, one such feature is advanced moderation. So right now, if you are in a single moderator kind of scenario, you can ask someone to unmute. So you can do this kind of interaction via the moderator. And before, this was not very possible. So we have all of these, I allow you to unmute, and then you go back to not being able, not to like disrupt the meeting. We recently had a little hackathon internally, and we had some cool projects, and I'm hoping that we see some of them also come to fruition. I'm not going to reveal those soon, but it's funny how when you look at Jitsi a year ago, you would imagine there was like it looks pretty complete in terms of what it's capable of doing, and yet there's always something else to do. So my expectation is that we continue adding things that people need, that people want. This was a long one in the making, but sometimes you just need for the planets to align and all the requirements to sort of line up so we can prioritize properly and make it work.
I mean, breakout rooms have been like on the table since like I started looking at the Jitsi project ages ago. Like people have been, it's probably the number one thing that people come to me as a consultant saying, "Oh, can you add breakout rooms into Jitsi?" And like it's always like, "Well, yeah, but
But
yeah." So the fact
yeah,
that it's part
it's
of the core project now is huge. And then moderation again, like again, people want to use Jitsi in new ways, and like having rooms that you can now have so many people in, you've really got to have the better moderation tools available to you as well. So, I mean, it's up and up and up for the Jitsi project, and I couldn't be happier.
definitely understanding these new use cases is what kind of brought some of them, because we used to be, I particularly used to be in denial about this large meetings thing, in the sense that it's like, what kind of meeting can that possibly be, right? It's like,
Right.
what kind of useful meeting? Let me qualify that, because you can put many people in a room, but it's not going to make sense, right? But then there is these very important high-profile use cases that weren't, like all hands, company-wide kind of things, huge assemblies, and the hybrid scenario where you have some participants in a live stream and some participants participating. I think it makes it clunky to jump between one and the other.
Right.
I'm not sure we're there yet into making something where you can seamlessly switch from one scenario to the other, and have it like pretend like nothing happened.
Mm-hmm.
So our solution was, and what everybody's doing is to basically cheat. So you're in a very large meeting, except that you're never seeing everybody, because there's never everybody emitting video. So we try to prioritize the information that's more relevant to you, and we've been trying to do this in other ways as well. Like if you try the latest version, we kind of stretched out all the video to kind of fill the screen, make sure that you kind of immerse yourself a little bit more, and you can see more of the content that it really matters. So that's why we sort of also played with how do we sort the tile view and who do we put first, like the people that have actively participated last. So we're always trying to continuously improve in these kinds of areas.
Fantastic. Well, thank you so much for joining us. Thank you so much for the talk as well. So we're going to be back later for another session today. But thank you very much for that. And that's it. That's it for now. We'll see you later. Thank you.
Thank you for having me.